Alright, you guys. For today's lesson, we're going to be looking at parallel lines and angle relationships that are created by crossing them with a transversal. And by them, I'm referring to the parallel lines. So what I'm going to start with is a quick drawing of two parallel lines. Okay, here we go. Two parallel lines. Now, what do we know about parallel lines? We know parallel lines never intersect. They go infinitely in both directions, and they will never cross each other's path. Now, a transversal is a line that crosses both parallel lines at the same time. Now, this is called a transversal. Again, a transversal is a line crossing both parallel lines. So what I'm going to do is go ahead and call these lines M and N, line M and line N, and then I'm going to call this transversal line L. Now, we're going to look at the different angle relationships. So I'm going to go ahead and give these angle names, okay? And we're going to say angle 1, 2, 3, 4, 5, 6, 7, 8. Okay, now looking at these angles, the names actually stem from the positioning of the angles. So if you guys pay close attention, you'll start to figure out that these angles are really actually easy to find just by dissecting their names. So let's take a look at the very first angle type. I'm going to begin with what I believe is like the easiest one, which is called vertical angles. Okay, vertical angles. Okay, and vertical angles are angles that pretty much share a vertex. So by looking at this two parallel lines cut by a transversal, you can tell that angle 1 and 3 are vertical angles. Again, they're angles that are formed by two intersecting lines, okay? And those angles share a vertex right in between. So 1 and 3 are called vertical angles. 2 and 4 are vertical angles, 5 and 7 are vertical angles, and so are 6 and 8. So I'm going to go ahead and just name a couple of these. I'm going to go with angle, okay, this is the angle symbol. Angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles as well. Next pair of angles we're going to identify is a little different. So we're going to call the next pair, here we go, let's see. The next pair of angles is going to be linear pair, okay, a linear pair. So linear pairs. Okay, and by linear pair, we're referring to angles that form a line. Okay, so they pretty much form a line. Okay, a linear pair, for example, is 1 and 2, 2 and 3, 3 and 4, 4 and 1. Could be 6 and 8, 7 and 8, 8 and 5, or 5 and 6. Again, there are any two angles that form a straight line or 180 degrees. So I'm going to go ahead and write a couple of examples. I'm going to say angle 2 and angle 3. Notice they extend with their outer rays to form a straight line. I'm going to also go ahead and name a couple more over here. How about 5, angle 5, and angle 6. And again, there's many, many more that we can identify, but I'm just going to go with only a couple. All right, next type of angles we're going to talk about. Okay, and by the way, these are also adjacent angles because they share a ray in between. Okay, they have a common ray in between. For example, 2 and 3 have this ray in between both angles, so they're also called adjacent. We can call them adjacent. Okay, now we're going to look at another pair of angles. So let's identify alternate interior angles. Okay, so I'm going to write the name alternate meaning different, right? Alternate, on opposite sides. Interior, angles. Okay, meaning they're on opposite sides of the transversal, but they're on the inside of the parallel lines. So let's go ahead and write those two words. Interior means inside the parallel lines, and then alternate means opposite. So they're on opposite sides of the transversal, but on the inside of the parallel lines. If you look at this and try to identify those two angles, you should be able to see that 3 and 5 are alternate interior. Again, they're inside of the parallel lines, but on opposite sides of the red transversal. So we're going to say angle 3 and angle 5 are alternate interior, and so are angles 4 and 6. All right, now you guessed it. If this is called interior, then there must be another pair that's called exterior. So let's go ahead and take a look at the exterior angles. Alternate exterior angles. Those alternate exterior angles are on opposite sides of the transversal, but instead of inside, these are going to be outside of the parallel lines. Outside. That's what exterior means. It means on the outside. So on the outside of the parallel lines, so they have to be here and here, and then they have to be on opposite sides of the transversal, meaning alternate, so meaning right there. So if we guess, here we go, angle 2 and angle 8 are alternate exterior, and so are angle 1 and angle 7 are also alternate exterior angles. Okay. Now we've identified a few of the different types. There's a couple more. There's angles that are called corresponding angles. Corresponding angles. Okay, so let's go ahead and identify corresponding angles. Here we go. Okay. Corresponding angles. Now, when I think of corresponding, I think of positioning in the same way, meaning when you look at two angles, you feel that their relative position is similar to the two lines that are parallel. So for example, what corresponding angles would be in this case are angles 2 and 6. So angle 2 and angle 6. Another pair of corresponding angles would be angle 4 and 8. Angle 4 and angle 8. If you guys started to notice, these angles will be, one of them is in between the parallel lines, but the other one will be outside the parallel lines. Another example of this would be 3 and 7 or 1 and 5. An easy way for me to remember is if I were to slide one angle into the other one's direction, they will give me a perfect overlap. So if I were to take angle 5 and slide it along the transversal, it will overlap angle 1. Okay, now let's see what other types of relationships we have here. We've identified so far vertical angles, linear pairs, alternate interior angles, alternate exterior angles, and corresponding angles. There's another one that's called same side interior and same side exterior. Okay, again, if you dissect the name, you'll be able to tell what those are. Again, alternate interior and same side interior and same side exterior angles. So let's go ahead and begin with same side interior. Okay, so I'm going to write that over here. got only a couple more. Same. Not a very good pen. Okay, let's try a different color. Same side interior angles, meaning they're on the same side of the transversal and they're on the inside of the parallel lines. So again, same side, it means they're on the same side of the transversal, and interior means inside or in between the two parallel lines. So if you look at this, that would mean angle 4 in relationship to angle 5 are same side of the transversal, and they're on the inside of the parallel lines. There's another pair, which is angle 3 and angle 6. Now the last type of angles would be same side but exterior angles. So let's go ahead and identify same side exterior. Here we go. Same side exterior, meaning on the outside of the parallel lines, but same side in relationship to the transversal or the line cutting the parallel lines. Same side exterior. Okay, well, let's take a look at it. Same side of the transversal on the outside of the parallel lines. So that would give us a relationship between 2 and 7. Angle 2 and angle 7 are same side exterior. There's another pair. Yep, you guessed it right, angle 1 and 8 are also same side exterior angles. That concludes the angle relationships between all types of different angles that are produced when a transversal line L cuts through two lines that are parallel, such as M and N. They are lines that never intersect. Okay, that concludes today's lesson. If you guys have any more questions, you can always ask me during conference or email me with questions.